But yeah, my day to day is very different every day, which is kind of exciting because, like for me, if I'm on a same routine every day, I could probably get bored while at work. But every day is totally different, and that's what makes it so fun. But usually I'd come in and check on what issues might have happened throughout the night. Some people in the lab work late shifts, and my shift is 9 to 5, and so those who are staying up till 7 p.m. or even 10 p.m. If they ran into issues, then I would come in and see if there's any unattended issues in one of our robots or instruments. I go troubleshoot that. If I'm not in the lab, either qualifying the instrument or qualifying a new method that I developed on the instrument, and just in general, kind of maintaining the quality of the lab and the instruments there. I'm usually just looking for new ways to automate our workflows in the lab, introducing new instruments. There's always these new companies come out with new technology, different features, and that's kind of a good gateway for the tools that I use. Every specific instrument has its own tool, and it can kind of get very hard. You're constantly learning like new ways to program an instrument because they have their own built-in software or tool for it. But what's nice is that some of them have Python enabled or C programming enabled, like custom scripting that you could do to develop your own methods like in-house. And I'm starting to do that as well. So Python and C are probably the main two right now. I'm learning SQL for database management and querying. But yeah, and a lot of Excel as well. A lot of our systems, we've taken CSV files to read them and run a protocol. And yeah, we also use laboratory information management systems, where essentially all the data that you need, like labware types or sample types and run times and the steps in which like all your workflow is going to go through step 1, step 2, it's all recorded in that system, so that in the future, if somebody will want to run another run that was similar to their peers, they can always go into that LIM system that we call it, and go to one of their peers' protocols if they know that they ran a protocol and they want to add on to it, remove some things, replace samples. And so instead of going back and redoing a workflow, you can always use different references, and it's very, very helpful to us, like as automation engineers, to track what's the use time of these instruments. Some of these instruments have different like deck layouts where they can put on plates. So what's the best configuration of the deck where they don't have to keep rearranging the deck and things like that. So different optimized things that we do. Yeah.
Very cool. So it sounds like Python, C, Excel, and VBA are still industry standards, and I'm very glad that our students are knowing how to use all of those.
Yeah, it's good.
So I will say, yeah, there is this new tool that I'm really excited to use. It's called BrainCube, and it's just this company that started in 2007. They've slowly been, making its way around the paper industry. But what BrainCube does is it kind of makes a digital twin of your mill. So it takes all your unit ops, puts it in like a modeling software, and then one thing that we're trying to do is leverage it to save money, right? So if you have a twin of your mill, of your plant on the computer, you can say, hey, using previous data statistically, if I change the flow of this pump to double, what happens downstream, what happens upstream, so that is something that I'm pretty excited to learn about and use. And we just started just 2 months ago, so we're still in the commissioning phase, but
Very, very cool and very interesting. I've heard about digital twins in the biology research area as well. Now, Vincent, can you tell us a little bit about how you're using some of the ChemE classes that you took, or maybe some of the ChemE electives that you took to be a process engineer?
Yeah, and this, I would say all the classes there, really teach you how to be a good process engineer in like the paper mill industry, refineries, a lot of old school stuff. And, every class that I've taken, except for probably quantum mechanics, I use at the mill here. So mass and energy balances, right? So we have a big, large, scope of the mill, but we also go detailed level. So if I want to make 2,200 tons of paper a day, how much chemicals do I need? How much pulp do I need? And then going down to a smaller scale, if I put 400 gallons per minute into a tank and only pull out 320 gallons per minute, well, that tank's going to accumulate, then it's going to overflow. And then what do you do with all the overflow, right? So pulp inventory management and stock and chemical inventory management is a big part of my job here, making sure that we have what we need to get our customers the paper. But even thermal, right? Like you guys learned about the ideal gas law. So we had a problem where, our one of our tanks was pulling vacuum every 30 minutes. And we're like, why is this happening, right? Well, it just so happened that every 30 minutes, a pump would kick on based on level and put a whole bunch of cold liquid in that tank. So you put cold liquid in the tank, your temperature drops, then your pressure drops, and then, so you use a lot of the concepts you learn in school. You don't exactly do a lot of detailed design and calculations in manufacturing. One thing I am proud of, though, is using Raoult's law and a bunch of those vapor liquid equilibrium calculations to really optimize what temperature we run our distillation column at. So that was pretty cool. But yeah, cool. Everything you learn in school, you'll see out here. And, even manufacturing, even though it doesn't teach you a lot about design skills and, detailed calculations, I feel like in a manufacturing setting, it still teaches you enough to be a professional engineer, I would say. There's a license by each state, the NCES, PE license, and, normally that's more geared towards consulting. But, with my manufacturing experience, I was able to take that test and pass it like 2 months ago without barely studying, just because I was so in tune with, all of those concepts from work.
That's very amazing. Very great to hear. So, Yusuf, do you mind telling us about maybe your favorite elective that you took as an undergrad, or maybe the most useful elective that you took as an undergrad to help you for your career in automation?
I guess it's a little bit difficult because then, like before, like there wasn't really a lot of, or at least I didn't really look for like automation specific like electives that I would take. Mm-hmm. I kind of got like introduced to the field kind of late, even like after I graduated, like in 2020, which pretty much means that it's never too late to introduce yourself to a new field that you find exciting. Like for me, I always gravitate towards like innovation, and so if you do gravitate towards innovation, you're always going to find new fields that emerge that you could be interested in. But I'd say I took microbiology as an elective, and that really helped a lot in terms of kind of understanding, especially at my old job, how bacteria and microbes work to, how they replicate, and because you have to keep in mind, the replication rates and all that stuff, like to understand how you're able to manufacture biologics at a larger scale. But some core classes that I took at ChemE that helped a lot was, of course, the material and energy balance. I treat like the people in the laboratories and the materials and the consumables that they use as the materials, and the energy is like, the consumption and kind of like the energy saving, electrical that electrical energy that's used to run our instruments. We have somebody on our team who, they use like a flex sim model, which is essentially like a for optimizing operations at a larger scale. And so he's kind of like, looking into all that. And also fluid dynamics as well. We do a lot of, liquid handling. So we encounter different types of liquids with different properties. And so we work with blood samples, and blood samples clot, over time. And so you have to kind of like work your way around that. How do you develop a protocol so that, your blood doesn't clot or anything like that in the pipette tips. We deal with very viscous samples. So being able to understand like how much pressure you're driving to generate the flow, and how fast you're pipetting also has an effect, because you don't want any air bubbles or anything to form in your samples. And we deal with samples that are like multi-component, so like DNA with other buffers and reactants and things like that. So yeah, it can get very frustrating sometimes. There's a lot of like testing involved, and understanding the science is very important. Like on a micro scale to be able to on a macro scale control it. But yeah, I say another class was process systems and controls. At my old job, we actually used like a lot of industrial scale instruments, like you would see in a factory, to do some of those like biological work, which is very cool, because you see like a factory doing like micro scale like reactions and things like that. So I have a video of a process running, doing like a PCR reaction setup. I could share it now if that's okay. Yeah. So on the left side, there's a carousel that has a bunch of sample plates that the operator loads up, and then you kind of see on the left, like there's an arm that grabs the plates, transfers the plates to the station. The station has a plate peeler. The plates are sealed. You can see it's going into the peeler now. And then here it is, transporting the plates. And then it goes into like a liquid handler where it transfers samples, arrays the sample out to different plates, because there's different reactions it's going to go through. And on that right side of that stacked hotel that we call it, it's putting plates there to wait for the next step. So it puts plates there. The arm is busy, or an instrument is busy until the instrument is done with that plate. Then the next one in the sequence continues. So you're able to automate a full laboratory like biological assay or workflow in the same amount of time that a person would take, and you can generate 8 times the output, 10 times the output, and the operator doesn't have to do anything but press buttons and load a carousel. So very cool, like seeing how this technology is headed. By no means is this replacing operators. Like there's fears where is this replacing lab people or operators, and I say no, because these are not AI intelligent. They're not artificial intelligent machines. You need people to operate them. You need people to like create the samples and load them up and all that stuff. So you're still utilizing the same number of operators. It's just that labor work is done by a machine where it's more consistent. There's not a lot of room for human error, and it gives also like our lab workers or technicians or operators to set up new protocols or runs while this one's running. So it saves them a lot of time too.
Really enjoyed seeing that the automation has a very physical component. It's not only automation of virtual workflows, but there's a robot that you're controlling as well.
Yeah.
Now, I think it'll be a great time now to transition to some questions from the audience. I'm sure there's many who want to ask all of you other things.
What is a large, or some examples of large professional mistakes you've made, and what you have learned from them?
I think one professional mistake that I made was not pursuing an environmental concern early in my career. You know, we were working an outage, you know, a 18-day shutdown. You know, it was during startup. So I've already been working like 16 days straight, 12-hour days just to get our plant back up and running. And well, we had an incident where, you know, I said, you know, mass and energy balances, there's a tank, you know, 400 gallons per minute going in, 320 gallons per minute going out. Well, we didn't know that the tank was overflowing for like 5 hours. And there was a lot of chemical that went to our water treatment facility and really overwhelmed our water treatment. But I knew that there was something wrong in our sewer, you know, since the beginning of that. But I lacked the leadership to get my operators to take a step back from starting up, because, you know, they worry about startup a lot, where, you know, they have a pressure that they put on themselves that production is very important, right? If we don't make paper, we don't have a job and things like that. So I wish I had taken a step back, did a round table, you know, got everyone together to start looking for where this sewer or where the chemicals in the sewer were coming from. And I didn't do that. It was night shift, everyone was tired, and, you know, it's just something that I learned from. If I notice that there's something wrong, just, you know, take a step back and reevaluate the plan. And, you know, it ended up being like 2 days of lost production time. It was like $500,000 or something. Of course, there's a whole team involved, but, you know, I was one of the leads for the night shift during startup. So.
Oh, great answer to that question.
Hey, but we also didn't put any of the chemicals to the river where we discharge.
That's important. Yeah.
Yeah.
Thank you.
So we actually, you know, shut down the mill and let the microbes in the aerated stabilization basin eat up the chemicals. So
Yeah, I was thinking about some experiences that I had, but we had an incident once where we had two, you know, liquid handling instruments stacked on each other, and on that instrument you have like a waste chute to you know, eject the tips, and the top one wasn't really well aligned to eject the tips down into the waste chute, and so it would fall into the one below it and would get into like the hardware, you know, like the pipetting hardware, what we call the core head, like the 96 well stamping pipetter. And at the time, I was usually the one that would go in and you know, check on the instruments, doing a lot of maintenance stuff and maintenance work. But I didn't go deep enough to, you know, check the head to see if there's any, you know, discarded tips or fallen tips in there, because there wasn't really a need to do that. It didn't. It wasn't a requirement in the maintenance, or like it wasn't a recommendation from the vendors to do that type of check on the maintenance. But because we had stacked these instruments, which usually they're not stacked on top of each other, they're on their own bench. This is kind of like a different setup, and we didn't know what was going to be the issues or the problems that was going to arise from it. But there was one day where someone entered the lab and they noticed a smell of something burning, and quickly we kind of like evacuated the lab to kind of assess what it was, and it was coming from one of the instruments, and it was that bottom instrument. And so we shut off both instruments. Luckily, there was no smoke that we visually saw. And then we brought the vendor in to kind of see like what's going on. Like, there's something burning. Like, is it a wire? Is it what? I don't know what it is. It didn't smell like an electrical burning, so it's just like a weird burning smell that I didn't know. That the tips are made with a kind of like a carbon fiber material that's conductive, because there's there's like liquid handling or like liquid detection that it does. When it goes to a liquid sample using connectivity, it detects that there's a sample in there or what the volume of the sample is. And so it's, there was that burning smell, and the vendor came in and they checked the entire system and found that there was like these little tips in there, and they were slowly getting melted because like the instrument was being in use. So yeah, like overlooking something or not thinking about like what maintenance tasks that you could do to prevent something, it could eventually have like a negative effect, and something worse could have happened. Glad nothing too bad happened. And these are like $200,000-$300,000 machines, so that was totally busted. That bottom one.
Yeah.
So yeah.
Both of these sound like very expensive mistakes, but like you said, very good that no one got hurt.
Yeah, exactly.
We have some other questions in the chat, and we have at least one other question in the audience. So let's take that question from the audience, Elizabeth, if you may.
Megan was asking you, Yusuf, what factored into your decision of getting a master's degree? And then more specifically, more broadly between both of you, Vincent and Yusuf, how much does having potentially a secondary degree or a postgraduate degree factor into your day-to-day? Is it something that you both have considered or had to consider even in your first few years of work?
Yeah. So while I was, completing my ChemE program, I was actually working in a material science lab for a project, and I was given the opportunity to get my master's paid for, to get it done, or like just continue on the project and complete the project and just take the courses for that year. And so the potential of me getting an advanced degree and doing it only for a year, actually, well, I graduated in 9 months. Like I did it even in less time. And so I just took that opportunity to get that advanced degree. I was working with microbes and working on a way of how you can biologically develop new materials. And so it was kind of in line with kind of like the work I wanted to get into. And in that lab, I also introduced a new liquid handling machine. I installed one myself, developed protocols on it to run my samples or my reaction plates, and that's what ended up ultimately cutting my time and fast tracking my research and my thesis. And that's kind of how that introduced me to automation as well. And so there wasn't really a correlation between material science and automation. It was just that's kind of how it happened, because I found the value of automation in the lab because of it. But I do use some skills that I learned. I learned CAD software, or to 3D print some tools that help us in calibration or testing of our instruments. So yeah, there's definitely things that I still use today from those.
Great answer. So we have 10 minutes left. I'm just going to go through some of the questions that we have from the audience that were sent to the chat. So maybe Vincent, do you mind taking this question? Do you work with instrumentation technicians often, and how is that relationship like? So I know you mentioned working with operators. So
yeah. One of my favorite things about working in this old school manufacturing is working with like the more blue collar type jobs, instrumentation technicians, electrical technicians, operators, millwrights, mechanics, pipe fitters, all that. And I think one thing that the ChemE, Capstone really puts into context is teamwork, right? So in the beginning of working here, you have to build relationships with everyone so you guys can, work an effective team. And, a lot of times, when something's wrong out in our process, it's all hands on deck. Instrumentation techs will be there, electricians will be there. millwrights and stuff, like, okay, what's wrong with this? And, you know, and that respect there, we do work together a lot. And if you don't have a good relationship with your operators and technicians, then, you know, they won't be as willing to help you, I guess. And, you know, they won't be backing you the whole way. So, you know, one thing that I try to do is get donuts and lunch for everyone every now and then. But yeah, we definitely work with them, those guys a lot. And
that's great to hear. I think the people aspect of engineering is always very important. As engineers, we have a role that usually transcends many different types of jobs within a company. I got a question in the chat here from Yusuf. You mentioned that automation doesn't replace people, but it seems like you hear a lot about this being a very big fear for our future. So what do you think is the future of AI and automation and manufacturing? Will it eventually replace people?
Well, I personally haven't heard any. So what I meant about like people who express fears is like, in general, you might express fears, but I haven't heard any fears. I've heard only positive things from introducing like automation into their workflow. I don't know too much about AI and how that's going to be incorporated into laboratory automation. The only way I think like AI could be enabled into it is, you know, if they interpret data or provide some kind of, you know, value. But I feel like it'll be more the future of AI and automation will be more geared towards kind of like business value, like, yeah, I don't know how to express that too well, but
yeah, no,
yeah.
I have thought about this question a lot myself, and I think it's very likely that for every job that AI replaces, maybe 2 or 3 jobs are created. We can do more if we can streamline tasks and do more complex things a lot more quickly.
With the automation we have now, I think of it more as it's a tool for you to be able to do your work more consistently and easily. Like, and I feel like the way, you know, people are doing things in terms of pipetting, at least with your hand, like we have technology now that can do that, you know, for you, like and it's a tedious task that, you know, can be time consuming, and you can also, you know, replace that time to do research or you know, develop your new protocol you're going to run later. So it's ends up saving you time, saving the company time, saving the company money. So yeah, and you still need the same number of operators. That's I never saw like any less you know, any cut on operating like people who are operating in the labs, and because of automation instruments. So yeah, I think it's too much of a concern.
That's good to know that robots will remain our friends.
Yes.
So next question, for the roles that you're in, so this is open to either Vincent or Yusuf, is the capstone necessary, or was it better to pursue research during undergrad? And compared to doing research in the lab, which one is maybe more helpful or less helpful for your career? Or are they both helpful? Also a possibility.
I can start.
Go for it.
Yeah, they were both helpful. And with the capstone, you know, solve a general, you know, engineering problem that, you know, the world is facing. And like Vincent was saying, like there's a lot of teamwork that teamwork skills that you develop from it. Learning how people on your team work, like that's a very big part of it. Is like, you know, what's their working style like, and how do they approach solving problems, and how can you tailor your communication, how you want to, you know, communicate your ideas or your problem solving to that person, and work with them efficiently. Compared to doing like research in a lab, like that definitely helped me how to approach problems myself. Like if knowledge of a certain process or an instrument that I work with is not well known, like how do you go and find and research yourself that new emerging technologies or new ways of developing these protocols. Yeah.
Vincent, do you have a answer you want to give to this?
Well, the only thing, I didn't do any research in undergrad really. I had an internship one summer and I was like, oh, this isn't for me. I'm not going to pursue it anymore. I have to play basketball or something. But in terms of Capstone, one thing that I would really suggest is, there's a standard Capstone that you can do, which most people do, but then there are some Capstone projects that are industry backed. Like if Boeing has a problem that, and they want to have an engineer work with you guys to develop a solution, like a real life solution. There was also a biotech company that worked with UW ChemE too for a Capstone, requirement, replacement, substitute. And I really think that if I were to go back, I'd probably do one of those. There was also an entrepreneurial one too that is really cool. You have a team of ChemE students and you can recruit an MBA or Bio-E or electrical or something, and you guys all work together to develop new solutions to problems out in the world. And I think I would have done one of those. That said, though, the normal Capstone was pretty cool too.
Very, very great. So we're going to keep taking questions from the audience for 4 more minutes, and then we'll move into a lightning round to finish off any other questions we haven't gotten. So the next question for both of you is, what are your 1 to 3 year professional or personal goals in your current job?
My goal is to just keep having fun. So there was a long time, my first year and a half, where I was like, okay, there's a couple different ways I can take my career. I can be more of a people manager, manage ops, manage budgets, all that stuff, where I can really dive deep in the technical route and be like, okay, do I want to be an expert in boilers, turbines, and evaporators and stuff? And, I tried a little bit of both. I like the more technical side, but I think as long as I'm having fun, then I'm not going to worry about it too much. I've made 5-year plans 5 years ago and they never go according to plan.
Yeah.
But that said, I still do want my PE license. So I passed the test. Now I have to wait for my 4 years of a professional work experience. And I'm applying to a process controls position right now that just opened up in the mill. And I think that would be fun.
Great. And Yusuf?
Yeah, I think I'm going to stay in a technical role. I find it a lot of fun, coming in every day to play with robots. I think that's fun. The other route could be a leadership route, but for me, I just see a lot of politics that become involved in that. I'm not cut out for that. So yeah, in terms of a 3-year, 5-year plan, yeah, of course they don't go according to plan, but I'm hoping to just progress into the field that I'm in, and maybe progress to a senior level role, and hopefully to a more kind of principal level or more like an automation architect role. So yeah.
Great. So question from Elizabeth is, Vincent, you're the first person to mention PE exam. Now, for our audience who might not be familiar with the PE, what is the PE? Can you tell us what it is, what's required for the exam, and what's required for you to get a license?
Yeah, so the PE exam is I think a federal approved license. I think they're given by each state that tells you, they give you a certificate that says this person knows the fundamentals of chemical engineering and he can apply these fundamentals in a professional work experience. And really what they give you is a stamp, and that stamp lets you stamp new drawings, construction drawings, saying, yes, this is not a safety hazard to your community and to your people. And really it gives you You know, it just says that this work is ethically safe, and it's definitely not required in manufacturing. But I wanted to take it as a test to prove that I have the chops to be an engineer, and that I know all the chemical engineering principles. And you know, there are consulting firms that do all those calculations where they would need it, but manufacturing is not one of those. I just took it as a personal challenge.
Are there any benefits that come with having a PE license?
Job satisfaction.
Job satisfaction.
No, not really. It could differentiate your resume. You know, saying that, okay, this guy really is technically sound, but from what I know, no pay raise or anything. If I wanted to go to consulting, I can jump ship, but I like where I'm at right now.
So it sounds like it's important for consulting. Now, you also mentioned that you have to work for 4 years to get the license. Is it a number of hours you have to work or a certain type of role?
I'm not exactly sure about a certain number of hours. It is, you need 4 years of work experience, and then you need to have 5 professional engineers sign off saying that, yes, this guy can do the work. So you meet professional engineers along the way, and you know, you need them to back you as well. So
that's really great. So now let's move on to our 2-minute lightning round. Do we have any quick questions here to ask? Oh, so I asked these questions. So what are the best decisions of your career thus far? In 2 words or less. Just kidding.
Staying technical.
Staying technical. All right, Yusuf.
Okay. Wow.
Lightning. Rapid fire.
Sometimes lightning is slow, right?
Sometimes lightning slow. Yeah, I guess not being afraid to, you know, jump into new tasks, new opportunities, new like innovational, like, or even, you know, going between different jobs that, like, you know, essentially is a good opportunity for you. So, you know, taking on opportunities as they come.
Great.
Yeah.
Be brave, take risks.
Be brave. Yep.
So second question, what excites you about the future of automation and or manufacturing?
Well, lightning answers, it's literally everywhere. Longer answer is, you know, the carbon capture side of
Yeah.
manufacturing, you know, capturing
Great.
all that CO2. How are we going to do that?
Yusuf.
Yeah, similar answer to me. Like, as for me, as long as there's labs everywhere, right? There's always some like ways to automate it. So as long as there's, you know, biotech or labs anywhere in the world, any lab could be automated. So it's definitely, yeah, it's always there.
All
You
right,
can't
so
automate Elizabeth's lab.
maybe in a few years, maybe we
Do you
have
want
better
something
AI.
automated?
So that is about it for our panel today. So thank you both, Yusuf and Vincent, for coming.
We'll do a round of applause in the room and for those online.